This is section 8.5, multiplying and dividing in scientific notation. Okay, let's take a second here to review. If you were going to multiply these two expressions together, all you would need to do is multiply the first two numbers, 3 times 5. That's going to give you 15. Then you have x's, which are bases, and they are alike. So if you have like bases and you're multiplying, the rule tells you to add the exponents. So if I add the exponents, I'm going to end up with 15 x to the 12th power. 7 plus 5 gives me 12. Okay, take a look at this. If you have negative 3 times negative 4, okay, you're going to multiply those two numbers first. Negative times negative gives you a positive. 3 times 4 gives you 12. Then you have a y here and a y here, like bases, so you're going to add the exponents. Just be careful here because this is a 1, okay, as an exponent, and this is a negative 3. So you're going to end up with 12 times y to the negative second power. You have 1 plus negative 3, which gives you negative 2. Now remember, if you have a negative exponent, okay, in most cases you don't want to leave that. You could take this y to the negative second power and you could drop it into the denominator and it becomes positive. Okay, so if you take a look on your sheet, you can see that you're going to fill in the blank here. It says multiply the numbers, leave the variables alone, and then add the exponents. Okay, and that's what we just did here. We multiplied the two numbers, and then we added the exponents since they had like bases. Alright, so that's just a review. Alright, so let's take a look at this. If we're multiplying two two expressions that are in scientific notation, what you want to do here is multiply the first two numbers, okay, so 2.3 times 3.1, and then you're going to add the exponents and you're going to leave the base of 10 the same. So let's try that right now. Let's do 2.3 times 3.1. Okay, and then we're going to be adding 4 and 5 together and leaving the base alone. So when you multiply here, you're going to get 7.13, and this is times 10 to the 9th power because 4 plus 5 gives you 9. And this is in true scientific notation. If you remember from the last lesson, we were saying this number here has to be in between 1 and 10. It can't be 10, but it has to be in between 1 and 10. Alright, so let's look at another example here. You're going to multiply the first two numbers. You're going to leave the base of 10 the same, and then you're going to add the exponents. Those are the 3 steps that you have to do. Alright, so you're multiplying 6.2 times 1.2, and here's where you might want to use your calculator to make the math faster. And then you're leaving the base of 10 alone, and you're adding the two exponents. So you have 2 plus negative 7. Alright, this should give you scientific notation as 7.44 times 10 to the negative 5th power. And this is in true scientific notation because 7.44 is in between 1 and 10. Alright, so give number 1 and number 2 a shot on your own. So take a second and multiply the first two numbers for number 1. So you're going to do 3.1 times 2. Okay, remember to leave that base of 10 the same, and you're going to add those exponents and see what you get. So for number 1, you should get 6.2 times 10 to the 2nd power. Okay, let's try number 2. You're going to multiply your first two numbers, leave the base of 10 the same, and then you're going to add the exponents. So for number 2, you should get 7 times 10 to the negative 6th power. And you're used to seeing decimals written here. Technically there is a decimal to the right of the 7. Okay, but in this case when you multiply the 5 times the 1.4, this gives you 7. And this is in between 1 and 10, so it does fit the scientific notation formula, where that A, which is here, has to be in between 1 and 10. All right, number 3 and 4, okay, same routine. Okay, you're going to multiply the first two numbers, leave the base of 10 the same, and then you're going to add the exponents. So for number 3, you should get 8.0898 times 10 to the negative 9th power. Okay, try number 4. Okay, for number 4, you should get 9.05 times 10 to the 0 power. Okay, if you remember from previous lessons, 10 to the 0 power, anything to the 0 power is equal to 1. Okay, this is written in scientific notation form. Okay, but if this turned into a 1 and you multiplied it by 9.05, the answer would be 9.05. But you want to leave it like this because this is in scientific notation form. Okay, so here's the part where it gets a little tricky. What if the product of the first two numbers is not in between 1 and 10? Alright, so this is where we're going to have to work out some things. It's not going to be as easy as the first couple of problems that you saw. Okay, so the steps are still the same here. You're going to multiply the first two numbers, keep the base of 10 the same, and then add the exponents. Okay, so let's take a look at that. After you do that, you're going to get 14.62 times 10 to the 2nd power. Now you're asking yourself that question, is 14 in between 1 and 10? Okay, and you know that it's not. So now you're going to have to figure out, well, how do I get it so that it is in between 1 and 10? Okay, well, what you want to do is turn this number, okay, this scientific notation expression, into an actual number, into standard form. And in standard form, the number is 1,462. And you're probably wondering, wait, how did she get that? Well, remember the decimal place is here. Okay, the exponent is positive 2. So I'm moving the decimal 2 places to the right. Okay, and I'm going to get this nice big number over here. And then what I want to do is work backwards. Okay, so I'm going to take this number here, 1,462, and I want to put this into scientific notation because it's going to change my exponent for my final answer. So remember, your decimal place is to the right of the 2. You're going to slide it 3 places to the left because that's going to put it in between the 1 and the 4. Your new number is 1.462. Okay, that's in between 1 and 10, so you were successful there. And then you're asking yourself, all right, well, how many spaces did I move? I moved 3 spaces. Okay, remember what we said before. If this number is a nice amount of money to get paid, that's a positive thing, and then the exponent's going to be positive here. So the final answer is 1.462 times 10 to the 3rd power, and that's in scientific notation. Okay, and this is just showing you here that if you were to work this number from scientific notation back into standard form, it would be the same as this scientific notation expression. Okay, so they're just showing you that no matter what, this and this both will give you back 1,462. Okay, so the trick. Okay, first it says write the number in standard form, which is the actual number. Okay, and then the second part of that is to work back into scientific notation, and this is going to give you your final answer. Alright, so we're going to solve the following. Okay, so we have 3 problems that are up here for us. So we're going to take this and we're going to put it into standard form. That's the first thing that we need to do. Okay, so the decimal place is to the right of the 0. Okay, if I move it into standard form, okay, I'm going to be moving the decimal to the right. Okay, I'm moving it to the right 5 spaces. My new number is going to be 474 million. And if you think of this as money, okay, this is clearly a good amount of money to have. Okay, so now the second part of this is going to be putting it back into scientific notation. Okay, so the decimal is to the right of the last 0. So to move it, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 places. Okay, 8 places to the left. So it's going to be in between the 4 and the 7. So the new number is 4.74. All those zeros can drop out. They don't need to be there. And I moved it 8 places to the left. Okay, and I know it's a positive exponent because this is a positive amount of money to have. Alright, so let's try that again. Okay, so the decimal place is to the right of the 6. I'm going to move it 7 spaces to the right. Okay, and I know that because the exponent is 7. So my number is going to be 560 million. Okay, so now I'm going to be putting it back into scientific notation form. So I'm going to be moving my decimal 1, 2, 3, 4, 5, 6, 7, 8 spaces. And my new decimal is 5.6. And in scientific notation, it's 5.6 times 10 to the 8th power, and that 8 is positive. Okay. Whoops, went a little too fast there. All right, so for number 3, you have the decimal point right here. Okay, let's put this into standard form. We're going to be moving it 3 places to the right. So I'm going to have 5.7. Okay, now this is in standard form. This is my actual number here. All right, and I want to put this back into scientific notation, and you're probably saying to yourself, well, it already is in between 1 and 10, right? Isn't that our goal always to have that first number in between 1 and 10? Well, the question would be then, if I'm not moving the decimal, well then what's my exponent going to be? So you can think about that for a second. Okay, well here it is, it's 0. Think about it, you didn't move anywhere. Okay, so if I'm not moving anywhere, then it is 0. 5.7 is already in between 1 and 10, so that's going to be a part of my answer. And I'm doing times 10 to the 0 power. And remember what we said, anything to the 0 power is really equal to 1. So what is 5.7 times 1? 5.7 times 1 is 5.7. Okay, so you can see how that works. Okay. All right, so let's take a look at what we have next. All right, so we have 4, 5, and 6, and we're going to do the same thing. We're going to put it into standard form, and then we're going to work our way back into scientific notation. Okay, right now this number is not in between 1 and 10. So let's put it into standard form, and in standard form we're going to have a number with a whole bunch of zeros, 4 zeros to be exact. Okay, this decimal was moved over 3 places to the left. Okay, now I'm going to work it back into scientific notation. I'm going to be moving the decimal 1, 2, 3, 4, 5 places to the right, landing in between the 7 and the 6. So 7.6 is my new number. All those other zeros can go away. Times 10, and then it's to the negative 5th power. Okay, remember that if this was money, this would be a negative thing to be given. It wouldn't be a good amount of money to have. Certainly would not be happy about that. And since it is a negative amount of money or a bad amount of money, you're going to have an exponent that is negative. Okay, so let's take a look at number 5 here. Okay, 75 is clearly not in between 1 and 10. Okay, so we need to move this and put it into standard form. Oh, went a little too fast there again. Okay, so in standard form, you're swinging the decimal 5 places to the left. Okay, and you're going to get 0.0007553. And once it's in standard form, you want to move it back into scientific notation. You're going to swing that decimal over and get it in between the 7 and the 5, because 7.553 is in between 1 and 10. Okay, so you have 7.553 times 10 to the negative 4th power. You moved your decimal place 4 places to the right. Okay, for number 6, 46 is not in between 1 and 10 clearly. Okay, the decimal place, even though it's not written here, is to the right of the 6. Okay, so you want to swing that decimal place 1 spot to the left. So you're going to have 4.6. Oh, I'm sorry. Let's take that back. You are going to be putting this into standard form. See how easy it is to make a mistake here. Okay, take your time with this. Don't rush it. Remember, standard form first. Okay, so the decimal place is here to the right of the 6. You're going to follow this exponent, which is negative 3, which tells you to move it 3 spots to the left. Okay, so you're going to get 0.046. Now you want to take this number here and you want to put it into scientific notation. You want that decimal to land in between the 4 and the 6. So you're going to move it 2 places to the right. So you'll have 4.6 times 10 to the negative 2nd power. Okay, here's a couple more. So I want you to take a look at these. Now you try them. Okay, see how you do with them. Okay, so for number 7, if you put it into standard